Hi students, today we can study about next symmetric cryptographic algorithm, that is IDEA. So we had already discussed about AES cipher, also R-Cipher algorithm. So in this module, next portion is IDEA, International Data Encryption Algorithm. Okay, so it's a symmetric block cipher mechanism. That is, it's a block ciphering. Also, it's a symmetric cryptographic mechanism. What do you mean by symmetric cryptographic mechanism? We can use the same key for the encryption as well as decryption. Okay. So, what are the plain text block length and plain text length and the key length for the IDEA? For IDEA, we have a 64-bit data block, 128-bit key. Okay, so the two inputs for the IDEA algorithm, 64-bit data block and 128-bit key. And they are invented by Lai and James Massey. And what is the design principle that is behind the IDEA? Here we are using some mixing of arithmetical operations from different algebraic groups. So here we are using a number of arithmetical operations. That is the design principle of IDEA. Okay, and the main operations that we are used in IDEA are XOR operation, addition modulo 2 raised to 16, that is an additive operation or addition operation with mod 2 raised to 16, and also we have a multiplication modulo 2 raised to 10 plus 1. Here this IDEA does not contain any S boxes or any table that's used for the permutation or substitution process. Okay, so the IDEA, it is a symmetric block cipher algorithm, and plain text length is 64-bit data, key is 128-bit key, and the main design principle that is behind the IDEA is mixing of arithmetical operations. So which are the arithmetical operations that is used in IDEA? The main arithmetical operations that we are used are XOR operation, addition modulo 2 raised to 16, addition modulo 2 raised to 10 plus 1. Okay. Also, the main feature of this IDEA is we have no S boxes or tables. Predefined tables are used here. Okay. So these are all about IDEA, features of IDEA. Next, we can see the structure of one round in a IDEA. So you can see in figure there are P1, P2, P3 and P4. We have R1, R2, R3 and R4. Next you have K1, K2, K3, K4, K5 and K6. Also you can see a red symbol, green symbol as well as blue symbols are there in this figure. So first, what is actually this P? P is the plain text data. Here the plain text is divided into 4 blocks, right? P1, P2, P3 and P4. Okay. So plain text length is 64-bit. So it is divided into 4 blocks means one block contains 16 bits, right? So we have 4 blocks of plain text and each block contains 16 bits, total 64 bits. Okay, after first round we get another 4 blocks. They are R1, R2, R3 and R4. Actually this structure is the first round or the single round of a IDEA. Okay, after first round we are getting R1, R2, R3 and R4 as the blocks. Also, you can see in a particular round, you have 6 keys are there. K represents the key which is used for a particular round, or the sub keys which is used for a particular round. So for a particular round, we have 6 sub keys are there. K1, K2, K3, K4, K5 and K6. Next we have 3 symbols are there. One is a red symbol, next is a green symbol, next a blue symbol. Blue symbol is for XOR operation. Okay, and red symbol is for multiplication modulo 2 raised to 10 plus 1. It's for the multiplication. Okay, multiplication modulo 2 raised to 10 plus 1. Okay. Next is the green symbol which is used for addition modulo 2 raised to 16. Okay. So these are all the symbols that is used for performing 3 operations in a IDEA. So we have a plain text as P, and we have a cipher after first round is R. All the plain text as well as the cipher are in a 4 blocks. Each block with a 16 bits, right? So for a particular round, we have 6 subkeys. Subkeys are used, K1 to K6. And what are the operations that is performed in a particular round of IDEA? They are XOR operations. Next, addition modulo 2 raised to 16. Multiplication modulo 2 raised to 10 plus 1. Okay. So now we can study the round transformation in a IDEA. Okay, there are 14 steps for a particular round. How many steps for a round in IDEA? 14 steps are there, or 14 procedure steps are there. Okay, so first you can see P1 data block is multiplied with K1. You can see in figure P1 multiplication modulo with K1, right? So first red symbol has 2 inputs. What are they? P1 and K1. Next, you have an addition operation for P2 and K2. Next, you have a addition operation for P3 and K3. Next, we have a multiplication operation between P4 and K4. These are the first 4 steps for a IDEA. Okay, so first we are multiplying P1 with K1. Next, we are performing an addition between P2 and K2. Next, we are performing an addition operation between P3 and K3. Next, we can see in between P4 and K4, you are performing some multiplication. Okay, so you can see in figure the round transformation 64-bit data is divided into 4 16 blocks. So these 4 blocks are processed through 8 rounds. So first round is as explained in the we are explaining in the first figure. So total 8 rounds are there with 6 16-bit key. You can see in figure K1 to K6 are there. K1 to K6 6 sub keys with 16-bit key is used for a particular round. Okay, so in round transformation you can see the first 4 steps. What is the first step? P1 into K1. We had already discussed. P2 plus K2. Next addition. P3 plus K3. Then P4 into K4. Next, 5th and 6th operation. Step 1 is XOR with step 3 and step 2 is XOR with step 4. Okay. So step 1, what is step 1? P1 into K1, right? That is XOR with step 3. You can see for a first blue symbol, you have two inputs, that is actually first step and third step. You can perform an XOR operation. Okay. Next, you have another XOR operation, that is in between step 2 and step 4. Okay. After this XOR operation, first XOR operation, you can see a multiplication operation in between the step 6 and K5. Okay. After XOR operation, what we are getting is the output, and that will be multiplied with K5. Okay. Next, you have an addition operation, and the input is the output of the multiplication between K5 and step 6. Then the output of XOR operation between P2 and P4. Okay. So you can see in figure 5, fifth step is step 1 XOR step 3. Next, step 2 XOR step 4. In the seventh process, we have a step 5 into K5. Next, we have 8th step, step 6 addition with step 7. Okay. Next, we have step 8. What is the output of 8th step? That will be XOR with K6. Then after that, we have step 7 plus step 9. Then 11 to 14, we have XOR operations between step 1 and step 9. That will produce R1. Next, step 3 XOR with step 10. That will produce R2. Step 2 is again XOR with step 10. That is equal to R3. Next, we have step 4 XOR with step 10. R4. So you can see in the figure, that is 11 to 14 steps, we are using step 1, step 2, step 3 and step 4, but XORing with step 9 and step 10. So 12, 13, 14 which uses step 10, and 11 which uses step 9 for producing R1, R2, R3 and R4. Also you can see in the figure, after the first round there will be a swap mechanism between R2 and R3. Okay, here R3 and R2 are swapped. So these are all about the round transformation of IDEA. So actually this is the one round, total 8 rounds are there. Here R2 and R3 are swapped, and we have a last round, that is multiply R1 with the first sub key. Then next step, not Y2, that is R2, add R2 and the second sub key. Next, add R3 and third sub key. Last one, multiply R4 and the fourth sub key. You are performing a last round. After 8 round, we have a last round of additional transformation is there, in which after the 8th round, you are getting R1, R2, R3 and R4. There will be an addition and multiplication operation between the first, second and third, fourth sub key and R1, R2, R3 and R4. By mistake, I have wrote there Y2, it's not Y2, it is R2. Okay. Okay, finally the ciphertext is the combination of R1, R2, R3 and R4. So it's available to everybody. It's used in wide range of application. Also, it is exported in worldwide. Also, it have a patent protector to prevent fraud and piracy. So it's a well-known or it's a best algorithm, symmetric algorithm, or it's a symmetric block cipher algorithm, that is IDEA, International Data Encryption Algorithm. Next, how the key scheduling is performed in IDEA. We have a very simple key scheduling algorithm. We have 128-bit keys. Okay. So it's divided into 8 16-bit blocks, in which first 6 bits are used for the first round. Okay. Okay, from this 6 keys, we are generating next keys in the next round. So total 8 into 6 keys are used for the 8 rounds. That is 48 types of sub keys are used. And last we have a special round, that is the additional transformation. For that, 4 16-bit subkeys are used. So total from 128, first we are dividing into 8 16-bit blocks. Okay, from that we are generating actually 52 subkeys are generating. First 48 for the 8 rounds, and for the last additional transformation we are using a 4 subkeys. So the total 52 subkeys are generated for the IDEA algorithm. So here the first 128-bit key is partitioned into 8 16-bit sub-blocks, okay, in which 6 are used for the first round, and then performing some shifting operations by 25 positions to the left. So after the left shifting operations, we are generating next 8 bits. That will be continuing for the 8 rounds for generating 48 subkeys. And the last we have 4 subkeys we have that is used for the last additional transformation. So the total 52 16-bit subkey blocks have been generated from the 128-bit key. So these are all about IDEA and its round transformation and the key scheduling algorithm. Okay, thank you.